Hello everyone, welcome to this statistics course for engineers. This course contains two important sections. One of them is probability, which is the prerequisite of statistics, and the other one is statistics itself, which will be about collecting data, summarizing them, and also analyze them, and at the end, try to report them. And through analyzing your data, I will also let you know how we can run hypothesis testing. So the things you should know before going through lecture one is that I want you guys to go through your course syllabus carefully. You will see, for example, the grading distribution there, and also what we are going to do weekly. So every week, I will send you videos related to lectures and tutorials. Please go through all of them carefully from the beginning to the end, because that's the main thing you need for your final and midterm exams. And also for practical assignments, which I will talk about in details later. There will be two practical assignments, and I will mention about them on Auto Class for sure. But for the time being, know that weekly I will send you videos related to your lectures and tutorials. And there will be a main textbook, which can be very useful for more practice. That's why if you see, for example, any conflicts between the lectures and whatever mentioned in the book, then consider the lectures, because that's what we will refer to in our exams as well. So when we say use our methods in the exams, it means that use the methods we describe in the lectures or tutorials. So if something is mentioned in the book and it's not in the lectures, it means that you cannot use them for the final or midterm exam. But they are good for practices, because there are some solved questions you can see in the book, which is good for more practice. And you can check with me whenever you see any conflicts. You can check with me whether there's a problem or which one you prefer and something like that. But as I said, for the final and midterm exam, you should follow the videos only. Okay, guys, let's go through lecture one, which is related to probability. As you know, the events around us in nature is not always 0 or 1. It's not, for example, like something happens for sure or something doesn't happen. We are dealing with probabilities in our life. Many processes, as you can observe in nature, they are uncertain. So in that case, we needed a science to deal with that. And probability uh, tries to deal with that by using probabilistic models. So the first thing we should know is about this notation, the simple notation to understand what we are talking about when we say probability of an event. So A here is an event, and this is the probability. So probability of event A is equal to number of outcomes which give A. So we should understand what is outcome. I will talk about it. And over total number of outcomes. You can show it by, for example, lowercase n over capital N. But we need to define also outcomes, sample space, and many notations so that we totally understand what do we mean by that. But to give an example right away, we could say if we throw a die, the possibilities are 1, 2, 3, 4, 5, 6. They are the outcomes. So when we say outcomes, we are talking about those possibilities. So 1, 2, 3, 4, 5, 6 are the outcomes of throwing a die. And what's the probability of receiving 1 or 2 if you throw a die? And this is an unbiased die. And we will talk about it. That what do I mean by that? By the way, when I say die, it means that just one. And also dice, it means that, for example, two die together, so we say dice. So throwing dice, it means that at least you should have 2 of them. Okay, so what's the probability of that? We have 1 and 2, so there are 2 outcomes. So 2 over, what are the all outcomes, the total number of outcomes? 1, 2, 3, 4, 5, 6. We have 6 of them. So 2 over 6. So the probability of receiving 1 or 2, if you throw a die, would be 1 over 3 or 2 over 6. So there are some rules related to probability which we should know from the beginning, that the values that you will receive for a probability should be between 0 and 1. Whenever it's impossible, then you say 0, and whenever this is for sure, you say this is 1. And to understand this part, which is the summation of all the probabilities related to the possible outcomes, it's better I talk about it when we define sample space, and also in the probability distribution, we exactly use this rule. So there I will talk about them even more. But also we should remind ourselves about the sets. So let's go through that. So I mentioned about sample space. What is that? Sample space is the set of all possible outcomes of a random experiment. So a set, we are talking about set. So you should know about your calculus and discrete mathematics for this course. It will be useful. If you know how to deal with sets, then you will have easier time dealing with, for example, sample space or probability, which we'll talk also after that. So here, for example, tossing a coin, you have 2 possible outcomes, head or tail. There is no other option. So the whole sample space is either receiving head or tail, and this is just 1 coin. Okay, if you have more, like for example 2 coins, then the sample space would be like this. Receiving, for example, tail for the first trial, and again receiving tail for the second one. So now your sample space will have 4 possibilities instead of 2. And sometimes you can see that the sample space could be defined like this. So not always it's countable. It could be like, for example, 0 to infinity. There are infinite numbers here. So the lifetime of a light bulb, for example, could start from 0, doesn't work from the beginning. For example, this is 0. Or it can work, for example, 2 years. So you can define this number in terms of years, minutes, or hours, depending on the problem. So you can define sample space like that. Like, for example, the sample space of cards. So we have these possibilities. If you have even joker in your cards, you can also include that. And you should remember the size of a sample space is different from sample space. Sample space was a set, right? So when I talk about the size of sample space, that you should count all the possible outcomes. And by the way, time to time you see, for example, the examples related to probabilities are related to the games that they usually play in casinos. And the reason is that even from the beginning, when they were scientists, when they were thinking about probabilities, it all started from these games. So that's why in a scientific point of view, even as examples, we give such examples which are related to such games. Like, for example, this game of roulette in casinos. Also, you can see, for example, if what's the sample space, then 0, 1, 2, 3 going to 36. And if I ask you what's the size of the sample space, what would you say? You would say 37, right? Because there are 37 possible outcomes. Or if I ask you what's the probability of receiving red for the first trial? So there are 18 of them, for example, here on this board. So over 37. So sample space, I think you got the idea what we mean by that. Now, what about event? You remember I said about PA, probability of A, and A is an event, is any collection of possible outcomes of an experiment. It means that, for example, if you are tossing two coins, you remember for this example, you are tossing two coins, then HT and TH, these two only, HT and TH, they could be an event, right? Or for example, HH. HH is the event that both of them will be heads. So each one of them, you can say as the subset of that set, we can consider them as events. So an event could be also the whole sample space. If that's the case, then of course we will receive 1. It means that this is for sure happening. So any subset of the sample space. So you see, we should know about sets very good in order to know about probabilities. We should understand that this is a set, not to confuse it, for example, with an element or with a value, something like that. Sample space even can be denoted by letter, like H or T. But we should remember that that's a set. And don't be surprised, sometimes instead of parentheses like this in front of probability, they use a set like this. Okay, so because they want to show that this is a subset. And a subset itself is a set. So sometimes they show it like this, and sometimes using parentheses doesn't matter. You can use either of them when we are talking about probability. But when we talk about the sample space, always remember to show them like this, like a set. Right, then there are different types of events, like some of them are simple, the other ones are compound ones. It means that a simple one is just a single event, which is very simple to deal with. Like, for example, HH, this is a simple event. But sometimes we are talking about, for example, the compound cases, like union of this one with another event. So in that case, all of them together would be a compound event. So now we should know about such operations on set. Let me remind you about them briefly. And before that, let me also talk about this part, like a sample space of n possible outcomes yields 2 power capital M possible events. And why is that? Because do you remember whenever we say how many possible subsets of a set can I have? How can I calculate it? By using this. This is the same. No difference between these two. All right, the sample space, we show it by this notation omega. And this is what we show in sets by universal set. So in terms of probability, omega is our universal set. This is very important to notice from the beginning. An empty event is that impossible event that never happens. And if I say what's the probability of a sample space, it means that all the universal set, so the probability of that one would be equal to 1. And what's the probability of an impossible event? Of course, this is equal to 0. So 1 is equal to probability of omega. Okay, and for each event also, as I said, you can even use a set itself in front of it or just use parentheses, doesn't matter. As long as you define this event carefully like a set, this is okay. So there are some notations. Again, if you took discrete mathematics, you will have easier time now. Just briefly, you can read them. I showed them all the details. For all x's, for example, you show with this notation. And for AND logic, you use this one. For OR, you use this one. So if you know logic related to the discrete computational structures that we talked before, so it's already there. And if not, I just explained here, and during the exercises, you will see that's easy to deal with. And by the way, you see this dash here, like this one means X belongs to, and here is the definition. This is not minus X, okay, be careful about it. Okay, set operations, like union intersection, complement, and so on. For complements, you can use either of them. Let me show you in examples. And by the way, about the difference, maybe it's better I explain it here. Like, for example, conditional probability, which I will talk about later, we show it either like this or with this straight line. And whenever you show it like this one means the difference, okay? Sometimes we confuse this one with other two notation, which is related to conditional probability. So be careful from here. Okay, let's go through the examples to show you, to just remind you, because I know most of you are already comfortable with it. Like if I'm interested to know what's the event, this is a compound event, right? Union A and B together. So it means that the elements, these are the elements of our sets, right? Because this is nothing different from the set theory. So these elements could either belong to A, B, or both of them at the same time. So 2 also belong to A union B. So all of these elements that you can see here belong to this set. What about intersection? A intersection B. We are talking about the common elements between them. So 2, 4, 6 belong to this set. And what's the size of that? For size, we usually use this notation, right? What's the size of it? This is 3 because it contains 3 elements. So we can have more sets and we can define union or intersections easily as the number of sets grows as well. And what about complement? For complement, it means that the elements which don't belong to A, for example, complement of A, you see that it was shown in pink color. And here also, here for the complement of B, whatever which is not inside this set B is the complement of B. So for example, if the element is here, it belongs to complement of B. If it is here, again the same. But if it is here or here, this is not an element of complement of B, which we denoted like this, with B prime, for example. And there are some useful equations that I've shown you here. Again, if you are familiar with set theories, it's very easy to understand. The only difference is that instead of universal set, we use the sample space. So if you just replace universal set with this one, it's easy to deal with. Let me also show you in pictures to understand better. And before that also, I explain you what are disjoint events and what are the exhaustive ones. Like whenever we are dealing with disjoint events, it means that those events, they don't have any intersection. So time to time, we get it confused with independent events. Independent events is something else. Disjoint events, it means that there is no intersection, like this picture, you see? There is no common element between A and B. So these two events are disjoint. But for example, this one is not. Because there are some intersection, like A and B are not disjoint. B and C, they are not disjoint. Any of them are not disjoint. What about exhaustive events? It means that the union of our events cover all the sample space. So in this case, you can see again that this is exhaustive. These are exhaustive events. But in this example, they are not exhaustive because it contains 2 elements which doesn't belong to either A and B. It belongs to omega. But here, as you can see, there is not, for example, some elements here or here because omega is exactly these sets, okay? So for them, we use the term exhaustive events. And I also given you some examples here. You can go through them. So if you know about set theories, again, set operations are exactly the same. So there's nothing to add here. For probabilities, it will work the same. It will, and also I will show you about the probability functions. And for equally likely events, these terms we use a lot, especially unbiased. It means that each one of these events have the same chance to happen. So if that's the case, we use unbiased. Like when an unbiased coin is tossed, the chances of getting head or tail are exactly the same. So what's the probability of receiving head? Is 1/2. What about receiving a tail? Is 1/2, exactly the same. If it's not the case, then we call it biased. The coin is biased. Otherwise, it's unbiased, which means the events are equally likely. Okay, guys, let me continue the rest of the lecture in the next video. Please watch all the videos carefully. And there are some explanations that I will mention after finishing the whole lecture one.